In this lesson, we're going to take a look at two examples of transforming logarithmic functions to take a base function and transform it somehow and draw the new function. One example on this page, and then there's one other example on the next as well. In this example, we're asked to graph y equals the log of x plus 5 minus 3. Now, if there's no base, then the base is automatically 10. And so what I've graphed here is y equals the log of x, or log base 10 of x. And so that's what the base function looks like. Now, in this function, there's been a horizontal translation of 5 to the left because of the x plus 5, so the whole graph has moved 5 to the left. Now that means that the vertical asymptote is no longer right here on the y-axis, but it's been moved again 5 to the left. So that's where the vertical asymptote would be. All logarithmic functions have a vertical asymptote. For the base function, it's actually right on the y-axis or the line x equals 0. Now the minus 3 in the end means that the function has been moved down 3 or translated down 3. So there's a vertical translation of 3 down. So for example, this point right here has been moved 5 to the left and 3 down. So I'll use a vector, an arrow to show that 1, 2, 3, 4, 5 left, and then 1, 2, 3 down. So that point's been moved to here. So if we actually draw exactly the same shape with that point moved to here, we'll have what the new graph looks like. And of course, this point here at 10, 1 is also moved 1, 2, 3, 4, 5 left, and 1, 2, 3 down. So locating a couple points, you can draw the graph fairly accurately. So that's what the function looks like. Now there is a vertical asymptote here. It almost looks like there's a horizontal asymptote, but it does actually rise forever, although it rises very slowly. Now we're going to also look, before we get into the second example, at a couple of features of this, domain and range, what the intercepts are, for example. So the domain, because this vertical asymptote, the graph exists only to the right of that, -5, x equals -5 line. So the domain would be all real numbers such that x is greater than -5, because it only exists to the right of that line. The range would be the entire set of real numbers. It does go for down forever, and it does actually rise forever, although it's a long ways out to the right before the y values do get very large. But the range is the entire set of real numbers. Now if we want to find intercepts, remember to find the x-intercept, you put y in place of 0 in place of y. So that's what I'm doing here. I'm substituting 0 in place of y, and we're going to solve to find what the x-intercept would be. And so in order to solve this for x, remember this is logarithm base 10, so bringing the 3 over to the other side, we would have the logarithm of x plus 5 base 10 equals 3. Now to solve this for x, we'll rewrite it in its equivalent exponential form, which would be x plus 5 is equal to 10 raised to the power 3. 10 raised to the power 3 equals x plus 5. So to find what x is, x would be this 10 cubed minus 5. And 10 cubed, of course, is 1,000. 1,000 minus 5 is 995. So really big x-intercept. It does cross the x-axis, but it is a long ways out to the right. That's the x-intercept. Now if we want to find the y-intercept, we will put 0 in place of x. We can see here that the y-intercept is something a little bit below -2 from the graph. We'll verify that that seems to be true. So putting 0 in place of x, we're going to evaluate the logarithm of 5, which is in your calculator 0.699, and subtract 3. So that's approximately -2.3. So that does agree with what's in the graph here. So that's what the logarithm of x plus 5 minus 3 looks like. One other example in this page, we're asked to graph the y equals 4 log negative 2x plus 6 and then plus 1. Now in order to see what the transformations are in here, we need to factor a -2 out of this -2x plus 6. So we'll do that first. So factoring a -2 out of -2x plus 6, we get -2 and then x minus 3. And then we can see better what all the transformations are. There are several with this one. The 4 multiplied by the logarithm means there's a vertical stretch of 4, which means y-coordinates are multiplied by 4. The -2 inside here, now it's inside the log function multiplied by the x term, And so the 2 here means there's a horizontal compression of 2, which means x values are divided by 2. Horizontal compression means the points get closer horizontally to the y-axis, so x is divided by 2. And this negative means they're actually divided by -2, so they switch signs, which means as there's a reflection in the y-axis. So points over here become points over here and vice versa. The x minus 3, that -3 means there's a horizontal translation of 3 to the right, so we're shifted 3 to the right, and then the +1 means there's a vertical translation 1 up. Now we're going to do these transformations in order. So the vertical stretch of 4, and I've identified 2 points in the graph. This is the point 1, 0, and this point out here is the point 10, 1. 10, 1 is on the basic y equals log of x, log base 10 of x, because 10 to the power of 1 is equal to 10. Now, for the vertical stretch of 4, y values get multiplied by 4. So if the y value is 0, 0 times 4 is still 0. So the vertical stretch does not affect that point right there. This point right here has a y value of 1. So when we vertically stretch it by a factor of 4, we multiply the y by 4. And so that would become the point 10, 4. So I'm going to plot the point 10, 4. This point stayed unchanged. So if you draw the general logarithmic shape like this, then that's what y equals 4 log x looks like, or 4 log base 10 of x looks like. Now we're going to do the take care of the horizontal compression and the reflection of the y-axis. And what that does is it divides all the x coordinates by -2. So if we divide 1 by -2, you get -1/2. We're only doing the horizontal, changing the x right now, so the y stays the same. So if we divide 10 by -2, that gives us -5. 4 stays the same. We're not affecting y at all here. So we'll plot these 2 points. -1/2, 0 would be right there, and -5, 4 would be right there. So if we draw our general logarithmic shape, looks like that. So that would be y equals 4 log of -2x. No translations right or left, up or down yet. Notice it's been reflected in the y-axis because it goes like this instead of like this to the right. Now we'll do the translations. Horizontal translation of 3 right, so we're going to add 3 to the x's. -1/2 plus 3 is 2.5 or 2.5. And a vertical translation of 1 up, so we add 1 to the y. 0 plus 1 is 1. I'll do the same thing with a -5, 4 point. So -5 plus 3 is -2, and 4 plus 1 goes up 1, goes to 5. So we'll plot those points. 2, 1/2, 2.5, 1, and then -2, 5. -2, 5 is there. And we'll draw our exponential shape, and that's what the graph looks like. This is the vertical asymptote for this. The vertical asymptote for the base function, y equals log of x, is right here on the y-axis. It's the line x equals 0. The only thing that affects where the vertical asymptote is the horizontal translation. So it's been moved 3 to the right, so that's 3 to the right. So this is the function we're looking for.